Hello, and a very warm welcome to all my young 7th grade scientist friends. Today, in this explainer, we're going on a super exciting journey together. We're actually going to track a single, tiny ray of light and uncover the absolute magic it creates all around us. So get ready to see your everyday world in a completely new way. But before we dive in, tell me something. Have you ever wondered how exactly you can see your own face when you stand in front of the mirror every morning? Or, say, after a rainy afternoon, where does that beautiful giant rainbow get all its magical colors from? Well, today, we're going to solve these exact everyday mysteries using some really simple physics. Section 1. The magic of bouncing light. You know, the only reason we can actually see anything in this world, your textbook, your friends, literally anything, is because of bouncing light, right? In science, we call this bounce reflection. Reflection of light is simply the bouncing back of light in the exact same medium after it strikes a surface. Think of it kind of like taking a tennis ball and throwing it hard against a wall. What happens? It bounces right back. Light does the exact same thing. Now, let's break down how we name these light rays when we draw our geometrical diagrams. The ray of light that's coming in from the outside to strike the mirror, we call that the incident ray. Remember, incident basically means it's arriving. And the ray that bounces off and goes back out, well, that one is perfectly named the reflected ray. But to measure this bounce properly, scientists created a sort of invisible helper. We call it the normal. Now, the normal is just an imaginary straight line. It stands completely perpendicular, meaning at exactly 90 degrees, right at the point where the incident ray hits the mirror. It's not a real ray of light at all, just a trusty helper line, so we can easily measure our angles. Section 2. The two laws of reflection. Light might seem like pure magic, but it actually follows some very strict mathematical rules. First step, the angle of incidence, which is the angle between the incoming ray and our normal line, is always absolutely equal to the angle of reflection. So if light comes in at 30 degrees, it has to bounce out at exactly 30 degrees, no exceptions. Second, the incident ray, the reflected ray, and the normal all lie perfectly flat on the same plane. Imagine them all staying flat on a single sheet of paper without popping out in random directions. But here's an interesting question for you. If light always follows these strict rules, why don't you see your face clearly when you look at a rough painted wall? Well, it's all about the surface. A perfectly smooth mirror gives what we call a regular reflection, which forms a nice, clear image. But a rough wall gives an irregular or diffused reflection, scattering the light in completely different directions. And actually, this scattered light is super important. It's exactly what lights up your entire room. Speaking of seeing yourself, let's look at what actually happens when you get ready for school in front of a standard plain mirror. The image formed has 4 really cool characteristics. First, it's a virtual image, meaning the light rays just appear to meet behind the mirror. Second, it's erect, which just means you stand straight up, you aren't flipped upside down. Third, it's the exact same size as you are. And fourth, and this is a fun little trick, it's laterally inverted. So if you wave your right hand, your mirror twin is waving their left hand. Section 3. Splitting light. The prism. Okay, so we've mastered bouncing light, but light has another mind-blowing trick up its sleeve. Look out your window at the bright sunlight right now. It looks pure white, doesn't it? But let me ask you, what is actually hidden inside that simple beam of pure white light? The answer might completely surprise you. You see, that white light is actually holding a very colorful secret. When we pass a beam of white light through a special triangular glass shape called a prism, the white light bursts open into a beautiful band of colors. This amazing phenomenon is called the dispersion of light. Basically, the prism forces the light to bend, and in doing so, it completely splits the white light into its 7 constituent colors. And what exactly are these 7 colors? They are violet, indigo, blue, green, yellow, orange, and red. To remember this exact order easily, just learn the super trick word VIBGYOR. You start from the bottom with V and go all the way up to R. VIBGYOR is literally the ultimate formula for white light. Now, what's really fascinating about this whole process is how the individual colors behave. Violet bends the absolute most. It angles sharply right toward the bottom of the prism. Why? Well, because violet has the shortest wavelength. On the other hand, red bends the least, staying right up at the top because it has the longest wavelength. This difference in bending is exactly why the colors separate so beautifully instead of staying mixed together. And because of these split colors, we arrive at another mind-blowing fact. Objects don't actually have color inside them, they just reflect light. Let's say you have a red rose. In normal white light, the rose absorbs all the VGR colors except for red. It reflects the red back to your eyes, so naturally it looks red to you. But if you take that exact same red rose into a completely dark room and shine only a pure green light on it, the rose absorbs the green, and since there's zero red light to reflect, it appears completely black. Isn't that just amazing? Section 4. Nature's Magic, the Rainbow. So, we can easily do this with a glass prism in a science lab, but what happens when nature decides to run this experiment on her own? You see, a rainbow is really just a giant natural dispersion. Right after it rains, millions of tiny water droplets are left floating in the sky. When the bright white sunlight hits them, every single tiny droplet acts exactly like a microscopic glass prism. It bends the sunlight, splits it into the 7 VGR colors, and splashes a massive, beautiful rainbow right across the sky. And do you want to know the absolutely craziest part about all this bouncing, reflecting, and rainbow making? It happens at a speed we can barely even wrap our heads around. The speed of light in the air is 300 million meters per second. To put that into perspective, that is a 3 with 8 zeros behind it. It is quite literally the fastest thing in the entire universe, working its everyday magic right in front of our eyes in just a fraction of a millisecond. So, my young scientists, today we've uncovered the strict laws of reflection and discovered how simple white light spritz into a beautiful spectrum. The next time you're brushing your teeth in front of a mirror or you spot a rainbow forming after a quick rain shower, I want you to ask yourself, what invisible rules is the light following right in front of my eyes? Keep looking closely at the world around you because science is happening everywhere, every single second. Keep learning, keep questioning, and thank you so much for joining me on this explainer. See you next time.